Oh, hey, Mike.
Hello, hello.
Hello. Mhm. Okay, no problem, Mike. Hello.
Hey, good morning.
Hey.
Thanks for joining.
Yeah.
I
Thank you for
saw your message. I think you you might have gotten a little bit confused with the time, but yeah, it's glad to see you here.
yeah. Can we start now?
Let's give it another minute and see if a few more people join.
Sure.
If
Sure.
not, then yeah, a couple 1-2 minutes. Yeah, and please add yourself as an attendee. I just posted the link.
Mhm.
Thank you. All right, I think we can get started. We got a good number. So yeah, thank you for joining. I'm excited to hear about open cluster management. So go ahead and take it away.
Okay. I will start by sharing my screen.
Yeah, perfect.
Okay. Can you guys see my screen?
Yep.
Okay. So today I'm gonna have a brief introduction about open cluster management, which is let's first of all let's take a look at our homepage. We are for now we are in CNCF sandbox projects, and our the scope, the mission of open cluster management is is a community-driven multi-cluster management platform that helps the Kubernetes admins to manage multiple Kubernetes clusters and orchestrate the applications across the clusters, etc. And if our time is sufficient, I will also have a brief demo in my local environment to show you guys how open cluster management is working from the perspective of a administrator. So we can probably start by taking a look at our architecture. So yeah. So overall, the philosophy of open cluster management is to manage the multiple clusters by abstracting them into managed clusters, and each of the managed clusters is also called clusterlet, and which is inspired by the original name of Kubernetes. So overall architecture of OCM is following the original architecture of Kubernetes. You know, in the Kubernetes, we have each of the kubelets is sending list watch requests along connections against the Kube masters, and they are all of these kubelets are like pulling the API models from the control plane and execute them. For example, list watching the kubelets is majorly responsible for list watching the pods and provision the expected containers on the machines. So this is how Kubernetes works. However, in OCM, our clusterlets is also list watching our OCM control plane. So we have a dedicated cluster we call hub cluster in OCM, which is similar to the original concept of Kube master, Kube API server, and the Kube controller managers. So we have two kinds of roles in OCM. One is hub cluster, and the other is clusterlet. This is inside of hub clusters, we have multiple operators, and the most important one is the registration operator, which is responsible for accepting the handshakes or the registration requests from the managed clusters. And after the request from the managed clusters are approved, then the hub clusters will be able to consistently send the tasks or the workloads, like distributing the workloads to each of the managed clusters. And then let's take a look at our core models. The first one is managed clusters. Each of the managed clusters are the interface or the models of the clusters that are registered into OCM control plane. So every time we are operating against the managed clusters, we will be sending the orders to the physical clusters. And as you can see in the status of the managed clusters, the real-time status of the underlying clusters will also be collected and reflected in the status of managed clusters. For example, the remaining memories, the remaining CPUs, and also a few metadata such as Kubernetes versions, and along with registering the managed clusters, the clusters can also be removed from the hub clusters in a really neat way. For example, we can simply unjoin a cluster using our command line libraries. Then everything will be automatically uninstalled from the managed clusters. And so this is managed clusters, and we have another outstanding model named the manifest work. We are like the manifest work API is helping us to deliver a list of Kubernetes resources to the to a few Kubernetes clusters. For example, in this we have a manifest work containing one deploy. So after we apply this manifest work to the hub clusters, then the am I lucky? It says my connection is not stable.
No, you sound okay. One question about this. I have a question. So
oh, thank you.
Yeah, what was the motivation behind creating a project like this? Is you had thousands of clusters, and then basically you wanted to find out a better way to manage them, or?
Yeah. So in the original Kubernetes community, we have KubeFed, KubeFed V1 and V2. But after we practice we bring the KubeFed V1 and V2 into our productions, and in our production of Alibaba Cloud, and we found that the original KubeFed V2 cannot satisfy our requirements in the number of the managed clusters. For example, we after like if after the KubeFed control plan adopts more than 40 or 50 clusters, then the control plan will be extremely busy at handling the request, and the process of distributing resources will be getting extremely slower. So we had so the original architecture of KubeFed is using the push model. For example, there's no agents in each of the managed clusters. The KubeFed control plan is just acting as a client of the managed clusters. It's just pushing API requests to those clusters. However, in OCM, we inverted the architecture to pool model. So each of the managed clusters will be planted an agent. The agents will be pulling these prescriptions from the hub clusters and do the execution. So by this way, we are able to offload some computations to each of the managed clusters. So this will be greatly improve the scalabilities in terms of managing more and more clusters. That's the I think that's the major goal, the major missions for us to innovate a new platform from the legacy multi-cluster community projects.
Got it. Thank you. Yeah, and have you actually tested the scalability, or how many clusters you can manage already with the tool already, or this is something like a work in progress?
Yeah. Like before like for a second. Like about 1 year ago, we bring OCM into production of Financial or Alipay, and we have about 100 clusters in the environment, and it proves to be working well. But there's no scalability like benchmarks for this criteria, because it's hard to measure how many clusters a multi-cluster control plan can hold at maximum, because the scalability also depends on the both the horizontal and the vertical size of the cluster. For example, how many nodes are there in each of the managed clusters, or how many like resources, for example, pods are there in the managed clusters. So but it also depends on how many manifest work, or how many tasks we're gonna apply to the hub clusters. But we can basically infer from the original technique, or the original pattern of Kubernetes, because the original scalability, the recommended maximum numbers of nodes in Kubernetes is like a 5,000. So because the OCM is basically having the identical architecture of Kubernetes. So I guess the OCM can host at most like 100 or like 100-ish clusters at maximum. But I think it's not a it's kind of difficult to measure how many clusters can a multi-cluster control plane hold, because it depends on many dimensions.
Got it. Yeah, that makes sense to me. Maybe the upper bound for scalability is like how much Kubernetes can scale up to in terms of nodes. And it sounds like you're doing a pull model, right? It's supposed to be a push model. And
yeah.
I mean, I guess you may not have the numbers of how your control plane can actually handle the request from all the nodes or something, right? So, but yeah, I mean, it's you know, I take it as a work in progress. Yeah.
Yeah. The significant benefits from the pool model is that we are offloading many tasks, many things that consuming the resources from hub clusters, from the central clusters to each of the managed the worker clusters. So for example, in OCM, registering like one worker cluster to the central cluster doesn't cost any resources, or doesn't cost too many resources. It's just a neat and lightweight registration agent. But if we are distributing, for example, 100 jobs to the worker clusters, then there will be no cost of computations happening on the central clusters, because all of the executions will be done in the worker, and the worker is responsible for doing the execution and uploading and reporting the status back to the central clusters. So basically, we can regard the central cluster as a static data plan.
Got it. Thanks.
Okay. So we can then we can start by note that there are also many core models in OCM, and most of them are optional, which means that you don't need to know about these models unless you hit the use case. So this is also the benefits. This is also one other merit of OCM, because the architecture of OCM is valuing the modularity, or the where is it? Yes, the modularity and the extensibility. Each models are building blocks. Like we can simply cutting off the building blocks from the OCM, and if we don't need them, and we can also simply add them back if we are if we will be using them like in our use cases. And we can from the perspective of a administrator of a Kubernetes or the administrators, we can take a look at. So we quick start documentation. First of all, that's still okay. Ways to install the official CLI, the command line libraries interface, which named the cluster ADM cluster the main. Yeah, we can easily download them, install them by
Hello, I think you kind of breaking up a little bit. So. Hello? Can you all hear me?
Hello? Yeah.
We can hear you.
Okay.
We could not hear Minky for a while.
Yeah, I think
Hello?
it's yeah.
Min, we can
Hello?
hear you now.
There?
Yeah.
Yeah, we can hear
Oh,
you.
great. Sorry. My network is a little bit laggy. Because I'm talking over an VPN. So anyway, so we can take a look at the movies over here. In this movie we have two clusters, and the upper part of the screen is the central cluster or the hub cluster, and the lower part is the worker cluster or the managed cluster. So we can simply, as you can see, we can simply initialize a hub control plane by running a cluster ADM inits. Then everything will be done automatically, progressively, and at the end of the cluster ADM command, it will generate a join command for you, so you can simply copy paste the command to your worker clusters, and this then the installations will be also done automatically. At the end of the join command, there will be a step command generated. So that the final step we need to do is to run the accept command. So this process of registration, registering clusters is called double opt-in cluster registration, which means that in order to establish the connections between the central clusters and the worker clusters, we need to require both sides of approvals. Like we need to start from the worker clusters, send a request, then the hub clusters will needs to approve that request. In the
how many Kubernetes question? Sorry to interrupt it. How many Kubernetes nodes you need for a control plane?
You mean the hub cluster?
Yeah, the hub cluster. Yeah.
It's only one clusters. So are you questioning about the high availability of hub cluster?
I'm asking about the size of that cluster. So does it have to be a big cluster, or does it have to be a small cluster, or it's a single node, or what?
Yeah, a single node cluster will be sufficient because but overall it depends on how many building blocks or how many modules you're gonna install on the hub clusters. If some modules are the modules are all optional, but some of them are data intensive, some of them are computing intensive. But a minimal installation of the hub cluster doesn't require many resources, because the minimal part of OCM is the registration operator, which is only responsible for like dealing with the cluster registration request, and also the registration operators will do something like probing the healthiness, and that's all of it. So it's not going to cost too many resources from the hub cluster.
Got it. And I guess the HA will be handled by just Kubernetes, like standard Kubernetes HA, which is, control plane. You have multiple nodes, and maybe you have multiple kubelet nodes.
Yeah, ideally we that's also another plan we're gonna do in the future. Ideally we're gonna make the hub cluster or the central cluster a node-free cluster, which means that there's another sub project named KCP, which is aiming at having a like pure control plane API, so could be API servers for managing the underlying clusters. So someday we will be running the control plan on the KCP. It's gonna like saving more resources from the hub clusters. But anyway, for now the hub cluster doesn't require too many resources. So so this is basically how the registration process works. Yeah. And we can move on and take a look at the how the multi-cluster resource distribution works. There's a
before you go anywhere, can I ask you a question? So how in this setup security is handled? So for example, like in some workloads on managed clusters needs to be run by a specific user and specific namespace.
Yeah. So I think I can address that question by this documentation, because for example, when we are distributing a workload to the managed clusters, all of the resources will be defined in one manifest work resource. So each of the distributing resources, their namespace and the name will be defined here. So for example, if we are sorry, let me think about how to put it. So you're saying about the securities. The overall the manifest work API is responsible for distribute these resources to the manager cluster, and the work agents in each of the managed clusters will be list watching the APIs and deliver that resources. So the identity, so the work agent will be mounting a service account, a local service account from each of the managed clusters. So we can, first of all, we can govern the permission of the work agents by controlling the scope of that service account, checking if there extra RBAC permissions are granted to that service account.
And practically, this agent is having unrestricted administrative access to a managed cluster, right?
Yeah. Oh,
okay.
I think I missed something. In the manifest work API, the namespace of the namespace of the manifest work API is actually the name of the managed clusters. So let's get back to the original architecture. After a cluster is registered to OCM's hub clusters, then the hub cluster, the registration operator in the hub clusters will be automatically creating a namespace, which has the same name as the registering managed clusters. And everything we put in that in that namespace in the hub clusters will be synchronized to the managed cluster. So it's kind of like we are squashing or mapping the managed clusters into the corresponding namespace in the hub clusters, and the agents in the managed clusters only has the RBAC permissions to the connected namespace in the hub. Managed cluster one can.
I'm asking about the opposite direction. So this work agent towards the managed cluster API server, it has unrestricted access, right?
Yeah.
Okay, yeah, thanks.
So it has some unrestricted access to the specific namespace on the hub cluster. So I guess.
Yeah.
Okay.
For example, if we have cluster 1, 2, 3, or managed cluster 1, 2, 3, then there's gonna be 3 namespace also named one cluster 1, 2, 3 in the hub clusters. And in Kubernetes we have a soft multi-tenancy by managing resources in namespaces. So the cluster 1 cannot see the resources in cluster 2, and the agents in each of the managed clusters will only list watch the resources inside that namespace, inside that granted namespace. That's how we do the multi-cluster multi-tenancy between the clusters in the hub clusters.
The reason for my concern was if you scroll back to your picture. Can you scroll back to your picture?
Okay.
So imagine the scenario. So imagine the scenario like someone gets access to the hub cluster and gets access to some specific namespace. Now he can run on managed cluster any kind of workload from any user within this managed cluster. That was my reasons for the questions.
Yeah. By default, the agents in the managed clusters will have a cluster admin access to the managed clusters, which means that for example, if anyone in the hub clusters has the access to the corresponding cluster namespace, will be able to do anything to the to the managed clusters. And we are so we have another proposal for like breaking down the permission of the agents into multiple roles, but it's still under planning. For example, we're gonna I think the basic idea is to separate the permissions of work agents by different instances. For example, work agent 1 has only can only operate the namespace 1, 2, 3 in managed clusters, and work agent 2 has the access to namespace 4, 5, 6. Then there's also gonna be a RBAC policies that manages the mappings between users and the certain the usage of certain agents. So but we didn't have I think this feature will be coming really soon in the future, and there's definitely gonna be more enhancements in permission governing in OCM. So there are many other modules in OCM, but for example, placement. The placement API is for the multi-cluster scheduling, and we also have other models named managed cluster sets, which is a group of managed clusters. So we can do the multi-cluster scheduling by creating a placement that matches against the cluster sets. But I think we're not gonna expand too much about these advanced modules today. If anyone is interested, you can take a look at our documentations over here. And also we have other add-ons that helps us to establish a connectivity tunnels from the hub clusters to the managed clusters, so that we can dial requests, so that we can push API requests from the hub to the managed clusters. No matter where the managed clusters network is managed. For example, even if there is a firewall between the hub clusters and the managed clusters, the hub cluster will always able to be sending requests through the connectivity tunnels. All of those is done by installing a few add-ons in OCM. It's cluster proxy, managed service accounts, and the cluster gateway. And speaking of add-ons, we also have a SDK framework named add-on framework. Where is it? Oh, never mind. I can open the rest for you. So it's a SDK framework for extending your custom modules in your OCM environment, which basically covers the installation of your custom agents to the managed clusters and the certificate rotation of those agents. And also the add-on framework help us to install some components, some services in the hub clusters automatically. There's also a few other modules in OCM, for example, the application management, etc. But there are too many modules in OCM. I think we are not gonna expand every of them today. And by the way, tomorrow we're gonna cut a new release of OCM, which is 0.6.0, and there are also a few many new features arriving. The Red Hat also write a blog about the new coming features, and yeah, the blog is over here. So for the guys that are interested in digging more about open cluster management projects, you can browse our homepage, and also we have a community meetings bi-weekly. You can find out what is planning or going on in our community by clicking into our Google Groups and join. And the schedule of our community meetings will be visible on your Google calendars, so you can join us every 2 weeks. And Slack, also we have a Slack channel, and so it's every contributions or participations in our communities are welcome. I think that will do today. Is there any more questions about OCM?
But you mentioned that you had a demo. Do you actually have a demo, or?
Oh yeah, okay. Yes, but I think I'm not sure. I think let's stick with the the demo movies in our homepage. I think we can schedule another time for detailed demo, because I'm afraid the having a full demo will need more time.
Yeah, no worries.
Then we
It's
have, like-
whatever you have, like a movie on the homepage works too. So.
Yeah, the movie is on our quick start page over here. And oh yeah, we also have many well, meeting records on the YouTube. So it's convenient to check out our history conversations meetings. We have like, so there's many video recordings over here. Is there any more questions?
Does anybody have any more questions about how to manage multiple Kubernetes clusters? Oh, yeah, I think no more questions. Well, thank you all for attending, and thank you, Min, for presenting. Looking forward to see more progress in the project. I think it's already in Sandbox, so looking forward to having more maturity and maybe continuing through like the different stages in the CNCF.
Okay, thank you for hosting.
Thank you. Okay, bye. All.